I work with DNA, our very own manual of life. It's in our blood, in every cell of our body, orchestrating our life processes. DNA is a ladder of just 4 linked molecules, A, C, G, and T, strung together in pairs in an incredibly long and complex sequence. If laid out, the DNA from one person would stretch to the moon and back 3,000 times. In our cells, this chain is broken into 46 bundles called chromosomes. Because of its sheer length, DNA is prone to develop small glitches in its sequence. They're called mutations. Everybody has them. When they occur, we pass them on to our children. We call these inherited mutations markers. As our chromosomes pass down through the generations, they carry these markers with them. They write our history. They are the source of our time machine, the way we can see back to our earliest ancestors. The markers I follow are found only in men, on their Y chromosome, the chromosome that makes men men. But of course, men don't travel alone, and the journey of man is the journey of everyone. I was walking through the village and I saw that they had massive piles of these sitting around everywhere. We call them monkey oranges. And they taste pretty good. They're a little bit like papayas. But I thought it would be a good idea to use them to explain exactly what we mean when we say we're following genetic markers. This is a man at some point in the past. The thing that makes him a man is his Y chromosome, a piece of DNA that's unique to men. When men have sons, they pass on their Y chromosome to those sons. Again, it's what makes them sons. So if we imagine that this man had 2 sons, they would have essentially identical DNA on the Y chromosome to their father. So they would get his Y chromosome in effect. And if we imagine that they also have sons, those sons, the grandsons of this very first man, would also have essentially the same DNA. But occasionally, we pass on these pieces of DNA, we get a change in a single letter in the sequence. We can call those mutations or markers, and that's what allows geneticists to trace descent. Now, I've represented this marker with a little strip of tape, a little black bar. And just like before, all of the sons of this particular man will have essentially the same Y chromosome, so they will inherit this marker. And in that way, the marker acts effectively as a badge of descent, a marker of descent from this particular man, and that's what we follow. Now, as we move further down the tree, most of the sons will inherit just that single bar, but occasionally, as we saw before, we will get a second change in the Y chromosome. A second marker appears, showing descent from a particular man, in this case this person, who has first that marker, which came from that person back there, but an additional unique change on his Y chromosome, which he then passes on to all of his descendants. So in the people that we're talking about living in the present day, in this part of the tree, they've got 2 markers. They clearly trace their descent from this man, but the first marker, remember, arose all the way back there, all those generations ago. The following day, I set out to sample an isolated village west of Madurai. This is exactly the sort of thing Luca started doing all those years ago. These villagers are a prime sampling group. They've lived in this region for generations with few outsiders marrying in. The more indigenous and isolated these people are, the easier it should be to find the ancient marker, if it's here. Name?
Rajendra.
And address? Genes are passed down through generations, so first off I take a detailed family history. Okay, age?
55.
And intercaste marriage?
Okay.
Okay. Mother tongue?
Mother tongue Tamil.
Okay. Religion?
Hindu.
Hindu. Remember, I only sample men? The thing is, without the male Y chromosome, my hunt for markers would be virtually impossible. Let me explain why. Chromosomes come in pairs. We inherit one from each of our parents. With each new generation, the 2 chromosomes get chopped up and reordered, making each baby a unique combination of their parents. When that happens, it's bad news for me because I lose my marker trail. It's chopped to pieces by this genetic shuffling. But the Y chromosome is different. It doesn't get reordered every generation. Instead, it passes unchanged from father to son. And so do its markers, creating a perfect genetic trail for me to follow. But of course, men don't travel alone, and the journey of man is the journey of everyone. Somewhere here, 50,000 years after his journey, I hope to find the marker of the ancestral grandfather of the Aborigines. It feels good to be out in the field. Every sample you take, you can't help but wonder whether this guy will be the one. But the next stop is the lab. There, it's death or glory. You thought I'd hung up my lab coat? Well, so did I. We've managed to collect several hundred blood samples from around the Madurai region. It's taken us days and days and days of work. And now we've got them in the laboratory. We've got a huge amount of work still to do. It's not just about collecting the sample, because we have to go through a purification procedure before we can get to the DNA and find this marker we're looking for. The first step involves getting rid of the red blood cells, the things that you might think of when you imagine blood, the stuff that carries the oxygen around your body. Then we get rid of the rest of the proteins, and we get down to a solution which is quite pure. We're ready for the last step, getting the DNA out of that. We want to add something to dehydrate the DNA molecules. So we add isopropyl alcohol. With any luck, we will see the DNA come out of solution. Looks a little bit like cotton at this stage. And there it is. I love this stage. I've done it thousands of times, and yet it still amazes me every time it happens. And it really is the essence of what we're looking at. This molecule is a historical document. Now, the final stage, down inside the solution, and snag the DNA, and lift it out. Voila, pure DNA. And there we go, and ready to move on to the next step.